So this is part 2 video for the rational and modulus functions inequalities. Now the first question is absolute value of x minus 5 equals to absolute value of x minus 3. So we have the roots as 0. For this one it is 0 and for this one it is 5. So these are going to be the roots. So I'm going to take negative infinity and positive infinity. I'm going to take three cases. So case 1 over here, if at all x is less than 0. If it was x is less than 0, so x minus 5 will become a negative number. So it becomes negative x. Then I move it over here so that it is easy to write. Negative x plus 5 equals to negative x negative 3. So we get 5 equals to negative 3, which is not possible. Now I take case 2. What is case 2? In case 2, x lies between 0 to 5. X lies between 0 to 5, and I take x lies between 0 to 5. Again, x minus 5 will become negative. So negative x, positive 5, and 0 to 5 will become a positive x minus 3. So what do I get from there? 2x equals to 8, x equals to 4. And in the third case, x is greater than or equals to 5. In that case, absolute value of x minus 5 will become a positive number, and absolute value of x is a positive and minus 3. Negative 5 equals to negative 3, which is not possible. So my only answer is nothing but what? X equals to 4 is only the solution. So every time try to take the roots and try to take the intervals between them. Question number B. What is B? Absolute value of x minus 5. Absolute value of x minus 5 is less than absolute value of x minus 3. Absolute value of x minus 3. So same case, the roots are negative infinity, 5, 0, 5 and infinity. So I'm going to take case 1, which is x is less than or equals to or less than 0. If x is less than 0, my left hand side is going to become negative. So negative x plus 5 is less than, again negative x, negative 3. So 5 is less than negative 3, which is not possible. Now case 2, x lies between 0 to 5. X lies between 0 to 5. In that case, 0 to 5, left hand side becomes negative. Negative x plus 5 is less than, right hand side becomes positive, minus 3. So what am I going to get that from there? 2x is greater than 8, x is greater than 4, x is greater than 5, greater than or equal to 5. In that case, both left hand side and right hand side becomes positive. X minus 5 is less than x minus 3, minus 5 is less than minus 3, which is not possible. So my final answer is x is greater than 4. Final answer is going to be x is greater than 4 is going to be the final answer. Question number 16. Draw the graph of f of x equals to absolute value of x minus 5 minus absolute value of x plus 3. Hence solve this equation. So first of all, what am I going to do? I am going to find it out the zeros of the moduli. What am I going to find? Remember the word zeros of moduli. Zeros of moduli. So when do I get 0? So when x equals to 0 and x equals to 5. So I'm going to find f of 0. When I get f of 0, what do I get from there? 5 minus 0 plus 3, which is 8. And f of 5. f of 5 will become 0 minus 5 plus 3, which is negative 2. Then we will be also finding one value before 0 and one value before after 5. One value before 0. One value before 0 is nothing but what? Negative 1. F of negative 1, if I find it out, 6 minus 1 plus 3, which is 8. And one value after 5, which is 6. F of 6, what do I find? it becomes 1 minus 6 plus 3, which is equals to negative 2. Now I'm going to plot all this on the graph. So when it is 0, x is 0, it is 8, and x is 5, it is negative 2. Then negative 1 is 8, negative 1 is also 8, and 6 is nothing but what? Negative 2. So I am going to get the graph in this way. This is going to be the graph. Now, what is he asking in the question? The first part of the question, f of x is greater than 0. F of x is greater than 0. When is f of x is greater than 0? For all x less than 4. X less than 4. Next one is f of x is greater than 4. F of x is greater than 4. We can see that this is at 4. That is 4. So x is less than 2. Next one is nothing but what? F of x is greater than negative 4. F of x is greater than negative 4. Negative 4 is over here. So for all the values, it is always greater than negative 4. So for that one, x belongs to R. And f of x is greater than 10. This is 10, and f of x greater than 10, no solution. So f of x greater than 10, no solution. Question number 17. Find all the asymptotes, horizontal, vertical, and oblique asymptote for this one. So vertical asymptote, so for that, denominator equals to 0. 2x square minus 14x plus 24 equals to 0. So x square minus 7x plus 8 equals to 0. It becomes plus 12 equals to 0. So it becomes x minus 3 times x minus 4 equals to 0. So x equals to 3 or x equals to 4 is a vertical asymptote. Numerator degree is greater than is equal to the denominator degree. So horizontal asymptote will be dividing by the coefficients y equals to 3 upon 2. So there is no oblique asymptote. Question number 18. Find all the asymptotes, horizontal, vertical, and what is this? Oblique. Vertical asymptote, denominator equals to 0. X square minus x plus 1 equals to 0. So this has no real solutions. No real solutions. No real solutions means no vertical asymptote. Now coming to the horizontal asymptote, degree of numerator is same as degree of denominator. So divide by the coefficients, 3 divided by 1, which is equals to 3. Coming to question number 19, find all the asymptotes of this one. So for the vertical asymptote, denominator equals to 0. 3x plus 7 equals to 0. So x equals to negative 7 upon 3 is going to be the vertical asymptote. Now coming to the horizontal asymptote. For horizontal asymptote, the numerator degree is greater than the denominator degree. So I'm going to do the long division. So it becomes 6x square plus 5x plus 1 divided by 3x plus 7. 3x goes in 6x square 2x times. So multiply with 2x. It becomes 6x square plus 14x. So subtract it out. It becomes negative 9x plus 1. Then again 3x goes in negative 9x, negative 3 times. So multiply with negative 3. So negative 9x, negative 21. So it becomes 22. So what will be the fraction becomes now? Y equals to 2x minus 3 plus 22 upon 3x plus 7. So the oblique asymptote is y equals to 2x minus 3. Question number 20. Find all the asymptotes again. The denominator should be equals to 0 for the vertical asymptote. So 2x square minus 14x plus 24 should be equals to 0. So which becomes x square minus 7x plus 12 equals to 0. So x minus 3 times x minus 4 equals to 0. So x equals to 3, x equals to 4 is going to be the vertical asymptote. Numerator degree is greater than the denominator degree, so I'm going to do the long division. 6x cube plus 0x square plus 0x plus 1 divided by 2x square minus 14x plus 24. 2x square goes in 6x cube 3x times. So 6x cube minus 42 42x square plus 72x. So when I subtract it out, change the symbols, 42x square minus 72x plus 1. 2x square goes in 42x square 21x times, so 21 times. So 42x square minus 14 times 21. So when I take the calculator and do 14 times 21, it should be 294x, then plus 24 times 21. 24 times 21 is 504. Then subtract it out, we get 42x square gets cancels. 294 minus 72 should be giving me 222x minus 503. So my oblique asymptote is nothing but what? Y equals to 3x plus 21 is going to be the oblique asymptote. Question number 21. Express this one in the partial fractions. So basically it can be written as 5 upon 2x square minus 14x plus 24 is 5 upon, take 2 common, so x square minus 7x plus 12, so which is 5 upon 2 upon x minus 3 times x minus 4. So that should be equals to a upon x minus 3 plus b upon x minus 4. So 5 upon 2 equals to a times x minus 4 plus b times x minus 3. Then I plug in x equals to 4. When I plug in x equals to 4, 5 upon 2 equals to b. And then when I plug in x equals to 3, 5 upon 3 equals to negative a. So a equals to negative 5 upon 3. So what will be the fraction now? Negative 5 upon 3 upon x minus 3 plus 5 upon 2 upon x minus 4. Question number 22. Express this as a partial fractions. So again, 5x plus 1 divided by 2 times of x square minus 7x plus 12 means 5x plus 1 upon 2 divided by x minus 3 times x minus 4 equals to a upon x minus 3 plus b upon x minus 4. So 5x plus 1 upon 2 equals to a times x minus 4 plus b times x minus 3. Then x equals to 4. When I take x equals to 4, 21 upon 2 equals to b. Then I take x equals to 3. 16 upon 2 equals to negative a. So a equals to negative 16 upon 2. So my partial fractions will become negative 16 upon 2 upon x minus 3 plus 21 upon 2 upon x minus 4. Question number 23. Solve the inequalities. Notice that they all involve the same factors. So what should I be doing it out from there? So we have to factorize it out. Once I start to factorize it out, x minus 1 whole square times x plus 1 times x minus 2 is greater than or equals to 0. So what are the factors? The factors are negative 1, 1 and 2. And I take negative infinity till positive infinity. So I take a number between, so the first one, x minus 1 whole square times x plus 1 times x minus 2 should be greater than or equals to 0. So I should be getting a positive number. So where should I get a positive number? So first one, I'll be taking it out between negative infinity to negative 1, maybe negative 2. If I take negative 2, this becomes positive, this becomes negative, and this becomes negative. So it is finally it is greater than or equals to 0. That's okay. Then I'll be taking between negative 1 and positive 1, maybe 0 I take. So this becomes positive, positive, negative, so which is less than 0. So this is not possible. Then I'll be taking what it says between 1 to 2, maybe 1.5. 1.5, it becomes positive, positive, negative. It is still what is as negative, so not possible. Then I'll be taking 2.5. If I take 2.5, positive, 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 so greater than 0, so it is there. So what is my final answer is going to be? My final answer is going to be negative infinity, negative infinity, negative 1, union, and at 1 also it is equals to 0, so the special case equals to 1, and again from 2 to infinity. 2 to infinity, that's going to be the answer for question number 1. So I erase all this and answer for question number 1. Now for part 2, x minus 1 whole square times x plus 1 divided by x minus 2 should be greater than 0. So what is that? X minus 1 whole square times x plus 1 divided by x minus 2 should be greater than 0. So therefore, numerator should be positive and denominator also should be positive for this. So how should I be doing it out for that? So if I take a number between negative infinity to negative 1, so maybe I take it out negative 2. If I take that negative 2, this becomes positive, negative, and this again becomes negative. So what it says, it is positive. So what I'll be doing it out, negative, positive times negative time divided by negative. So it is still greater than 0. So this value is there between negative infinity to 1. So this is okay. So negative infinity to negative 1 is possible. Now when I take the next one, between negative 1 to positive 1, maybe 0. If I take 0, so this is positive, then 0 plus 1 is positive, 0 minus 1, 2 is negative, so it is less than 0, so this is not possible. Then I take the value between 1 to 2, maybe 1.5. If I take 1.5, it becomes positive, again 1 plus 1.5 is positive and it is negative, so this is less than 0, so it is also not possible. Then finally I'll be taking 2.5, so it becomes positive, positive and positive, so therefore it is greater than 0, it is possible. So my final answer for part 2 will be negative infinity to negative 1 union 2 to infinity. That's going to be the answer. Now for part 3. Part 3 is same as part 2, only the difference is nothing but what? It is greater than or equals to 0. So we have to, what it says, for greater than or equals to 0, we have to exclude the roots of the denominator. So we have to exclude the roots of the denominator. Every answer is the same, but except x equals to 2 is not possible. The same answer I'm going to write, but exclude the roots of the denominator. So equals to 0. So minus infinity to minus 1 is also possible because I want equals to 0. Then again 1 is also possible because equals to 0. But root of 2 should be excluded. So union 2 comma infinity. That's going to be the answer. Question number 24. Solve the inequalities. So what are the roots? Half, negative 1 and 2. So I take negative infinity, negative 1, half and 2. So I am going to take 2x minus 1 whole square. 2x minus 1 whole square is going to be positive because positive, what is the square term, is always positive in all the intervals. It is better to take like this. It is positive in all the intervals. Then I take x plus 1. X plus 1 will be negative over here, and this is negative 1 to 0 is negative 0.9. So this is positive, and positive. Then 2 minus x. This is positive, and this is still positive, and it is still positive and negative. Now I want part 1 answer. So I want a positive. So the numerator should be positive. So you can see that totally numerator is positive. This is negative over here. This is positive over here, negative over here. So totally the what is this? It is positive between the limits minus 1 to 2. And it is equal to 0 is also there. So minus 1 comma 2. Minus 1 comma 2, it is positive. That is the first part. And should be less than or equals to 0. So it is in the first and the last case. So for that part 2, minus infinity minus 1 equal to, therefore, square brackets union, and it is equal to 0 at half also, and union again 2 to infinity. This is going to be the way. Question number 25. F of x is x plus 4 upon x plus 1, and g of x is equals to x minus 2 upon x minus 4. Solve the equation f of x equals to g of x. So without GDC, so what we can do it is graph f of x and graph g of x, and wherever they intersect, that's going to be the answer. So f of x equals to g of x. So the critical values will become x equals to 14, that is one of the root, x equals to negative 1, and x equals to 4. You can check from the GDC. Now f of x without GDC, if at all you want to do without GDC, then what am I going to do that? F of x is less than or equals to g of x. So x minus 4 upon x plus 1 minus x minus 2 upon x minus 4 is less than or equals to 0. So what does that becomes? X square minus 16 minus x square plus x plus 2 divided by x plus 1 times x minus 4 is less than or equals to 0. So from there, what do I get it out? X minus 14 divided by x plus 1 times x minus 4 is less than or equals to 0. So what are the roots I got it out? The roots are negative 1, 4, 14 and infinity. So I take any number between negative 1 to negative infinity. Maybe what it says, I take x minus 14. X minus 14 will be any number between negative 1 and negative infinity. X minus 14 will be negative. Then between this one also still it is negative. And 4 minus 14 is also negative. And 14 to infinity is going to be positive. X plus 1, this is negative. Any number between negative infinity to negative 1 will be negative. And From negative 1 to 4 will be positive. This is positive and positive. X minus 4. X minus 4, it will be negative, and it is still will be negative, and it is positive and positive. So now I want the overall combination of all those things should be negative. So this is positive, this is negative, and this is positive. So it is negative between x is less than negative 1 and x lies between 4 and 14. Now we have equal to, do we have equal to 0? So therefore equal to 14 is also going to be the answer. Question number 26. With GDC, draw the graph, solve the inequality. So when I'm drawing the graph over here from the GDC, I should be able to get in this way. This point is negative 2.3, this is 1 and 1.3. So therefore the critical values are negative 2.3, 1, critical values will be negative 2.3, 1 and 1.3, and my vertical asymptote is going to be x equals to 0. Vertical asymptote is x equals to 0. Question number 27. Solve the inequality given that one of the zeros of the function is x equals to 1. So x square minus 4 plus 3 upon x is less than 0. So I get x cube minus 4x plus 3 upon x is less than 0. Now if I factorize it out, it becomes x minus 1 times x square plus x minus 3 upon x is less than 0. So this is a quadratic. The roots of quadratic will become minus b plus minus square root of b square minus 4ac upon 2a. So negative 1 plus minus square root of 13 upon 2. Those are the roots. So now what am I going to do? I am going to take the number line. So negative infinity, negative 1, negative root 13 upon 2, then 0, then 1, then negative 1 or negative 1 plus square root 13 upon 2 and positive infinity. What are the things I need to check? X minus 1, then x square plus x minus 3 and the x itself only. So x itself is very simple. This is negative, negative, positive, positive, positive. Whereas x minus 1, this becomes negative, this still becomes negative, then still negative and positive and positive. Now between for the quadratic equation. So how should I be getting it out for the quadratic equation? So we know the roots are negative 1 plus root 13 upon 2 plus or minus root 13 upon 2. So between this one is going to be positive, and between the roots it's going to be negative, 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 and above the root is going to be positive. So now finally my answer is going to be positive, negative, positive, negative, and positive. So my final answer is when it is going to be less than 0. It is less than 0 between negative 1, negative root 13 upon 2 till 0, and also between 1 and negative 1 plus root 13 upon 2. Question number 28. So both are absolute values. So I'm going to squaring on both sides. So it becomes 5 minus 3x whole square is less than or equals to x plus 1 whole square. So it becomes 25 minus 30x plus 9x square is less than or equals to x square plus 2x plus 1. So it becomes 8x square minus 32x plus 24 is less than or equals to 0. 8 brackets x minus 1 times x minus 3 is less than or equals to 0. So x lies between 1 and 3. Again, question number 29. Squaring on both sides, x minus 2 whole square is greater than or equals to 2x plus 1 whole square. So x square minus 4x plus 4 is greater than or equals to 4x square plus 4x plus 1. 3x square plus 8x minus 3 is less than or equals to 0. 3x minus 1 times x plus 3 is less than or equals to 0. So x lies between negative 3 and 1 upon 3. Question number 30. So absolute value of x plus 9 is less than or equals to 2 absolute value of x minus 9. Squaring on both sides, x square plus 18x plus 81 is less than or equals to 4 times of x square minus 18x plus 81. So I get 3x square or x square plus 30x plus 81 is greater than or equals to 0. So x minus 3 times x minus 27 is greater than or equals to 0. So from negative infinity to 3 union 27 to infinity. Question number 31. Find the largest set of values of x such that the function f of x takes always real values with or without GDC. So graph the function. From the graphing, you can really get it out. X is less than or equal to 0.5. X is greater than 3. Question number 32. F of x is given, g of x is given. F circle g of x. So f of g of x. So f of g of x is x upon x plus 1. So 2 times of x upon x plus 1 minus 1. So that is f circle g of x. G circle f of x is g of f of x. G of f of x is nothing but what? 2x minus 1. Then 2x minus 1 divided by 2x minus 1 plus 1. So which becomes 2x minus 1 upon 2x. Now f of x is less, f circle g of x is less than or equal to g circle f of x. So 2x upon x plus 1 minus 1 is less than or equals to 2x minus 1 upon 2x. So what do I do from there? I bring all the terms on one side. So it becomes 2x upon x plus 1 minus 1 minus 2x minus 1 upon 2x is less than or equals to 0. So I'm going to simplify this one. So it becomes 4x square minus of 2x times x plus 1 minus 2x minus 1 times x plus 1 divided by 2x times x plus 1 is less than or equals to 0. So what this becomes 4x square minus 2x square minus 2x minus 2x square minus 2x plus x then plus 1 is less than or equals to 0 divided by 2x times x plus 1. So 4x square gets cancels. So it becomes 1 minus 3x upon 2x times x plus 1 is less than or equals to 0. So for this 1 minus 3x upon 2x times x plus 1 is less than or equals to 0. So what are the roots? Negative infinity then -1, 0, 1 upon 3, and infinity. So x or 2x. 2x is negative, negative, positive, positive. Then x plus 1. X plus 1 will be, it will be negative, and it will be positive, positive, and positive. Then 1 minus 3x. 1 minus 3x. Any negative number, it's going to be positive. This is positive, and this is still positive, and over here it will be negative. So overall, I want a negative number. So this is positive, negative, positive, and negative. So it is negative between -1 to 0, and it is positive negative between or greater than or equals to 1 upon 3, because I want equal to 0 also, greater than or equal to 1 upon 3. That's going to be the answer. Question number 33. Write down the equations of all the asymptotes for the graph y equal to f of x, g of x, and h of x. So part A, vertical asymptote, denominator equals to 0. Both the it's a bottom heavy equation, so horizontal asymptote y equals to 0. Part B, vertical asymptote x equals to 1, x equals to 4. Horizontal asymptote, both the coefficients are same, so divide y equals to 1. Part C, vertical asymptote x equals to 1, x equals to 4. Now numerator is greater than the denominator. Then once I divide it out, I'll get an oblique asymptote. Directly I'm writing it out. Oblique asymptote should be y equals to x. Part B, express f of x in partial fractions. 6 upon x square minus 5x plus 4 equals to a upon x minus 4 plus b upon x minus 1. So 6 equals to a times x minus 1 plus b times x minus 4. So x equals to 1, 6 equals to negative 3b, so b equals to negative 2, x equals to 4, 6 equals to 3a, a equals to 2. So what will be the partial fractions? 2 upon x minus 4, negative 2 upon x minus 1. Then express g of x in this form. X square minus 5x plus 10, x square minus 5x plus 10 divided by x square minus 5x plus 4. This can be written as x square minus 5x plus 4 plus 6 upon x square minus 5x plus 4, which will become 1 plus 6 upon x square minus 5x plus 4. Then express g of x in this form and h of x in this form. So part D, g of x equals to 1 plus 2 upon x minus 4 minus 2 upon x minus 1. H of x equals to x plus 4 upon x minus 4 minus 4 upon x minus 1. Part E, 5f of x is less than or equals to 3g of x. So 30 upon x square minus 5x plus 4 is less than or equals to 3x square minus 15x plus 30 divided by x square minus 5x plus 4, which gives me, if at all I do, directly I'm writing that 3x square minus 15x divided by x square minus 5x plus 4 is less than or equals to, is greater than or equal to 0. Then 3x times x minus 5 divided by x minus 1 times x minus 4 is greater than or equals to 0. So what are the roots? Negative infinity, 0, 1, 4, 5. So I talk about 3x, I talk about x minus 1, then I talk about x minus 4, then I talk about x minus 5. 3x is going to be negative, positive, 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 and again it's going to be positive. X minus 1, x minus 1, negative, negative, positive, positive, positive. Then x minus 4. This is negative, 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 positive, and positive. X minus 5, negative, 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 and positive. Now I want the overall. Overall, this is positive, this is negative, this is positive, this is negative, this is positive. I want overall greater than or equals to 0. So from negative infinity to 0, union 1 to 4, union 5 to infinity. This is going to be the answer. Finally, question number 34. Find the quotient and the remainder when x cube plus 50 is divided by x squared minus 6x plus 8. X cube plus 0x square plus 0x plus 50 is divided by x square minus 6x plus 8. X square goes in x cube x times, so x cube minus 6x square plus 8x. So it becomes 6x square minus 8x. Then minus 6x goes in minus 6x square. Minus 6 times or plus 6 times. Plus 6. So 6x square minus 36x plus 48. And over here plus 50 also. So what does that becomes? Cancels. It becomes 28x plus 2. So quotient is q of x is x plus 6 and remainder is 28x plus 2. Express this one in the form of this. So what is that becomes? X plus 6 plus 28x plus 2 divided by x square minus 6x plus 8. Write down all the asymptotes. So vertical asymptote will be x equals to 2, x equals to 4, denominator equals to 0. And the oblique asymptote will be y equals to x plus 6. Oblique asymptote is y equals to x plus 6. Next, we attain the partial fractions. 28x plus 2 divided by x square minus 6x plus 8 equals to a upon x minus 2 plus b upon x minus 4. So 28x plus 2 equals to a times x minus 4 plus b times x minus 2. Plug in x equals to 2. 56 plus 2, 58 equals to negative 2a. A equals to negative 29. Then x equals to 4. If I take x equals to 4, 32, 3, 814, 114 equals to 2b, b equals to 57. So what will be the partial fractions? X plus 6 plus 57 upon x minus 2 minus 29 upon x minus 4. 57. So over here the answer is going to be 57 upon x minus 4 minus 29 upon x minus 2. That's going to be the answer. So that completes the paper. See you in the next video. Bye.